The night sky has forever been a material of secret and marvel, a domain of vast potential outcomes and untold stories. For quite a long time, people have looked at the sky and pondered the presence of different universes and different developments. Could it be that there are other people like us? Imagine making a significant discovery that shakes our understanding of life beyond Earth's surface. The James Webb Space Telescope's groundbreaking discovery of city lights on an exoplanet, Proxima Centauri b, is told here. These lights point to the possibility of discovering an advanced extraterrestrial civilization. Go along with us as we dig into this unprecedented story, investigating the mechanical wonders and logical advances that have carried us to the capacity to respond to quite possibly of mankind's most established question: would we say we are distant from everyone else in the universe? It's amazing in a sweet and spiritual way. In the next 10 years, we are going to make a lot of progress. The lights of a city in space were found by the James Webb Space Telescope, 7 trillion kilometers from Earth. The significance of this discovery has piqued a lot of curiosity and inquired about the possibility of life on other planets. The closest exoplanet to Earth, Proxima Centauri b, was the focus of the telescope, and it revealed unusually bright lights coming from it. On Proxima Centauri b, what could be causing these city lights? Might this at any point demonstrate the presence of life past our own planet? Find out how these extraordinary space objects were identified by the James Webb Space Telescope. Lately, analysts and individuals all over the planet have been leading examination to find out about existence past our close by planetary group. Over the course of time, enthusiasm has been shown for any clear evidence in support of this space fantasy. The James Webb Space Telescope recently discovered convincing evidence of the existence of living things in space, shocking the scientific community. While investigating space and communicating significant information back to Earth, the James Webb Space Telescope saw uncommon lights blazing from the city of the exoplanet Proxima Centauri b. The city lights appear to illuminate a faraway city, as the name suggests. Researchers have been blown away by the possibility of a city on this star from another planet. Since it appears that this is the presence they have been anticipating, they are all perplexed. If this turns out to be true, which is what most people naturally think, it means that intelligent beings are coordinating civilizations in space that humans don't know about and that we are only just finding out about it. NASA experts can't help but wonder how long these city lights have been in space, waiting for humans to develop the technology to identify them, as they look at them 7 trillion miles away from Earth. David Kipping, a cosmologist at Columbia University, describes the Proxima Centauri system where the city lights were found as unstable. According to him, this is because the star system closest to us is altering its heating patterns. In contrast to other planets, this exoplanet's infrared radiation is very different from that of its host star, Proxima Centauri, which is known to absorb sunlight and emit infrared radiation. This perception from the James Webb Space Telescope, JWST, ends up being a pivotal one. The infrared frequencies and heat signature of Proxima Centauri b, which JWST is certain to be able to identify, will be crucial to understanding the planet's climate. This is thanks to the most recent upgrades in infrared imaging abilities that JWST has. Specialists intend to utilize the telescope to uncover the insider facts encompassing the planet's environment and conditions. Additionally, they intend to test the exoplanet's habitability with JWST. The James Webb Space Telescope's infrared reflectivity will permit it to explore what's going on the night side of Proxima Centauri b, catching even the littlest explosions of light in the magnificent cloudiness. Generally, catching the slightest explosions of light in the lofty dimness is quite difficult for space telescopes, yet not so much for JWST. It is the best tool for verifying rumors of city lights on the night side of Proxima Centauri because it can detect even the tiniest bursts of light from space. Telescopes can detect any artificial light source in the universe that has a frequency range several times smaller than that of starlight. How does the planet Earth compare to Proxima Centauri b? The relationship between surface interactions and celestial features on Proxima Centauri b is intriguing. The exoplanet's day side contains various sun-oriented power chargers that catch the splendid gurgling energy radiated by the star. Additionally, intense light beams are reflected at the spectrum's edge. Similar to Earth, Proxima Centauri b experiences daytime intense solar heat and nighttime coolness as it completes its orbit around its host star, Proxima Centauri. It is known that the planet's composition influences fluctuations in temperature. For instance, without a climate on Proxima Centauri b, the contrast between its day in and day out would be enormous and far separated. Without the defensive impact of an air, the day side would be pretty much as hot as a dark body while the night side would be dove into cold murkiness. The degree of the temperature variety is a fascinating point for space experts to investigate, prompting a more profound comprehension of the climatic structure of the Proxima Centauri range. With its unrivaled infrared imaging abilities, JWST can really look at the planet's warm emanations and give understanding into its air properties. It is interesting to note that JWST's orbit around Earth coincides with the orbital period of Proxima Centauri, making it possible to observe a complete day-night cycle for 11 Earth days. Assuming that it in all actuality does to be sure have a climate, the subsequent stage is survey the science of its environment to decide if it could uphold life. A few decent signs of livability incorporate the presence of gases like oxygen, water fume, and methane. It would indicate that the planet could support life if these elements were to be found there. Recognizing this peculiarity expects specialists to be careful in gathering and breaking down light emissions going through the planet's environment. This is no simple undertaking. Even though JWST is very good at describing the atmosphere of the planet, it also serves an important other purpose. The telescope is intended to break down changes in the centralizations of water fume, carbon dioxide, and methane. In any case, with regards to identifying bound oxygen, a vital evidence that something is going on under the surface, JWST is restricted. In any case, the telescope has valid justification to search for different components in the world. One of those reasons is ozone, which shows the well-being of the climate. It is also important to note that the James Webb Space Telescope is not a particularly powerful instrument. It can only conduct in-depth atmospheric analyses of some of the habitable worlds closest to Earth. Earth-based observatories like the Extremely Large Telescope, ELT, which will be operational in 2028, are now being utilized by astronomers. This telescope is positioned precisely to examine the atmospheric composition of distant exoplanets in greater detail and provide comprehensive and striking information regarding their habitability. Scientists at NASA. Cosmologists are not surrendering their endeavors to comprehend the attributes of exoplanets, so they are more ready to track down indications of something going on under the surface and recognize them from bogus upsides. The JWST mission has made significant progress in our understanding of exoplanets and sheds light on the incredible discoveries that remain to be made. As we extend our comprehension and investigation of the universe, we are better prepared to comprehend how it functions and the various jobs we play in it. Subsequent to concentrating on every one of the planets in space, scientists presently can't seem to track down a planet that upholds life in spite of looking for a really long time. The search for extraterrestrial life continues. Is it safe to say that we are distant from everyone else in the universe? Humans have pondered the possibility that we are the only species in the universe for as long as human history has existed. An old longing has not passed on us right up till now. The James Webb Space Telescope, which is currently in space, is being used by researchers to simultaneously examine a large number of planets for signs of life and look for signs of alien civilizations among us. The tale of outsiders trusting that people will find them is as yet a commonly known legend. To respond to this inquiry, two American stargazers, Jill Tarter and Thomas Pearson, sent off a task in 1984 called the Quest for Extraterrestrial Knowledge, SETI, otherwise called the SETI organization. Space transmissions are filtered through this charitable initiative so that only radio transmissions from space are received. Radio transmissions can travel huge distances without being dissipated or consumed like different sorts of radiation, pursuing them a decent decision for this exploration. On account of this trademark, radio transmissions are bound to be identified by the 42 radio telescopes that make up the Allen Telescope exhibit in the slopes of California. The SETI Institute has diligently looked for signs of these extraterrestrial signals, but it has yet to find anything that is not of human origin or made by a celestial body like a star. The dissatisfaction of not getting any correspondence from extraterrestrial developments has driven analysts to scrutinize their techniques and investigate elective ways of looking for proof of extraterrestrial life. The proceeded with look for these extraterrestrial signs, while as yet yielding no substantial proof, stays an imperative undertaking for stargazers. In 1961, American cosmologist and astrophysicist Honest Drake planned a condition to appraise the quantity of extraterrestrial human advancements. The terms that make up the equation, which is called the Drake equation, include the percentage of habitable planets where life develops, the percentage of civilizations that develop technologies that allow them to communicate over long distances, and the average amount of time these civilizations last. The Drake equation is a useful tool for determining the likelihood of extraterrestrial life, but it relies on a number of assumptions and is subject to uncertainty. Be that as it may, it fills in as a beginning stage for understanding the many variables engaged with the quest for extraterrestrial life and the expected presence of cutting-edge developments known to man. NASA scientists continue to look for signs of life on planets in our solar system and beyond. Despite the lack of conclusive evidence to date, each new discovery advances our understanding of the possibility of life beyond Earth. With the headways in space investigation innovation, for example, the James Webb Space Telescope, the quest for extraterrestrial life is entering another time. The conceivable outcomes are huge, and the mission to reveal the secrets of the universe proceeds. We are drawing nearer to understanding the idea of life in the universe and addressing the deep-rooted question of whether we are separated from everyone else in the universe. All in all, the disclosure of city lights on Proxima Centauri b by the James Webb Space Telescope addresses a weighty second in the quest for extraterrestrial life. This discovery raises exciting possibilities regarding the existence of advanced civilizations beyond our planet and opens up new horizons for exploration. As we keep on investigating the universe, the mission for understanding and finding life past Earth stays one of the most significant and rousing undertakings of mankind. The journey is far from over, and with each new discovery, we get closer to figuring out the mysteries of the universe and our place in it.